So, in the last class, we did for Bernoulli equation, how to find a solution for Bernoulli equation. There is another kind of Bernoulli equation in a form like this. Given f dash y dy upon dx plus bx fy is equal to qx. The equation is like this. Means there is some function of y multiplied with the part b and its derivative is multiplied by dy upon dx. So how to approach in such a problem? Take t is equal to fy, right? So then y is a function of x, fy is again function of x, of course t is a function of x. ठीक है ना? तो y x पे डिपेंड कर रहा है तो t भी x के ऊपर डिपेंड करेगा. तो मैं क्या कर सकता हूँ अब? I may differentiate with respect to x. Differentiate with respect to x. I shall have dt upon dx is equal to, for fy this will be f dash y, derivative with respect to y, and for y this will be dy upon dx. Is it okay?
Yes, sir.
और ये डेरिवेटिव किया मैंने, यहाँ पर चेन रूल लगेगा आपका. f y का डेरिवेटिव हो जाएगा y के रेस्पेक्ट में f dash y, right? And then for y it will be dy upon dx. चेन रूल यही है ना तुम्हारा, df upon dy into dy upon dx. तो अब इसको सब्स्टिट्यूट कर देते हैं. क्या बनेगा मेरे पास इक्वेशन में? dt upon dx plus pt is equal to qx. And now this is the linear equation in t and x. T is a dependent variable, x is an independent variable. Is it okay? t dependent हो गया और x क्या हो गया? Independent हो गया. Linear equation को कैसे solve करना मैंने बताया? इंटीग्रेटिंग फैक्टर निकालो. Where? This one. This is only dt upon dx. This is only dt upon dx. तो अब इक्वेशन को आप सॉल्व कर सकते हैं. उसके बाद t की जगह क्या सब्स्टिट्यूट कर दोगे? f of y. You will have a relationship between y and x, and that will be the solution of your original given ordinary differential equation. So is the method clear? So again we shall have solution for such type of equations. Is it okay? Right. Let me have one example. Okay. That is example dy upon dx plus write down y upon x into logarithm of y is equal to y upon x square into log of y all square. Is it okay?
Yes, sir.
What is the form there? What is there? Let me have some manipulation for this problem. What was the form? F dash y into dy upon dx plus b of x into f of y is equal to q of a. Is that okay? So just make some comparison. Make the comparison. The given equation is f dash y, if it is in form like this, plus p of f5 is equal to q. You will have to make some comparison. So let me do one manipulation. Divide by y into log y all square. Divide this equation. Y into log y all square. Then I shall have 1 upon y log y all square dy upon dx plus 1 upon x log y. Is it okay? And this will be equal to 1 upon x. So let me make a comparison. P will be 1 upon x. Here px is equal to 1 upon x and 2x is equal to 1 upon x square. Is it okay? So you need to put p is equal to 1 upon log y. Differentiate it with respect to x. I shall have dt upon dx. This will be equal to, now apply chain rule, 1 upon log y. This will be equal to minus. This will be equal to minus 1 upon log y all square, and then derivative of log y, that will be equal to 1 upon y, and then derivative of y, that is dy upon dx. So in this way I get 1 upon y log y all square dy upon dx. This will be equal to minus dt upon dx. Is it okay? So substitute here in the equation. Then I shall have g minus dt upon dx plus d upon x is equal to 1 upon x square. And this will be dt upon dx minus d upon x. This is equal to minus 1 upon x square. So now this is a linear one. This is a linear one in t dt upon dx. Now you can solve it. I'll leave it as an exercise for all of you. Okay? Now let me have a situation like this. If I am having a relationship between x and y like this, fx comma y is equal to c. This is an implicit expression of a function. Y is dependent variable, x is independent variable. अगर मेरे पास ऐसा कोई रिलेशनशिप है, implicit relationship between x and y, the function f is always constant. Is it okay? So let me introduce, or that has been already introduced, the concept of total differential. Then df is always equal to 0 because c is a constant. And applying the chain rule, df will be equal to del f over del x dx plus del f over del y and dy. So here in the situation, this expression is equal to 0. Is it okay? Is it right? So here, what is in this situation? If I am given some function f, the relationship between x and y is expressed implicitly fx comma y equal to c. I shall have a differential equation in this form: del f over del x into dx plus del f over del y dy is equal to 0. Or in other words, I will write down it as some, because again it will be some expression of x and y. So this I will write down capital M, a function depending upon x comma y, dx plus nx comma y dy is equal to 0. Is it okay? और अगर मैं इसका सीधे इंटीग्रेशन कर दूं तो मुझे क्या मिलना चाहिए? दिस fx comma y equal to c, क्योंकि डायरेक्ट डिफरेंशिएशन किया. तो ये जो सिचुएशन है, आपको कुछ इक्वेशंस की कैटेगरी देती है. द कैटेगरी इज कॉल्ड एग्जैक्ट डिफरेंशियल इक्वेशन एंड ऑफ कोर्स non-exact differential equation. So such type of examples motivate us to classify, to categorize the equations into two categories called exact differential equation and a non-exact differential equation. So after this motivation, let me define the exactness of a differential equation. Is it okay? The definition is exact differential equation. A differential equation of the form M.TECH plus N.dy is equal to 0 is called exact differential equation. If the solution can be obtained directly integrating the equation without any sort of manipulation in the equation. ठीक है ना? जो इक्वेशन दे रखी है उसका डायरेक्ट इंटीग्रेशन आप करोगे तो आपको सॉल्यूशन मिल जाएगा. अगर ऐसा है तो आपकी इक्वेशन कहलाएगी एग्जैक्ट डिफरेंशियल इक्वेशन. उस पूरी इक्वेशन में आपको किसी भी तरीके का कोई भी मैनिपुलेशन नहीं करना कि भाई किसी से मल्टीप्लाई कर दिया, किसी टर्म को या डिवाइड कर दिया. नहीं, नथिंग इज टू बी डन. जो दिया हुआ है उसके डायरेक्ट इंटीग्रेशन से अगर सॉल्यूशन मिल जाता है, अगर मिल जाता है तो इक्वेशन क्या कहलाती है? एग्जैक्ट डिफरेंशियल. Let me complete it. A differential equation M.TECH plus N.dy is equal to 0 is called exact differential equation if the solution is obtained by direct integration of differential equation without any sort of manipulation, without any sort of manipulation in the differential equation terms, right? Otherwise it is called a non-exact differential. otherwise it is called non-exact differential. Is it okay? So this is the classification of exactness and non-exactness. In the next lecture I shall have what are the conditions, what are the conditions that will define the exactness of the differential equation. यानी कि कौन सी कंडीशंस ऐसी होंगी कि जो कंडीशन हमें ये बताएंगी ये डिफरेंशियल इक्वेशन मेरी एग्जैक्ट है या नहीं, ठीक है ना। और साथ में ये भी देखेंगे कि वो कंडीशंस मेरी नेसेसरी भी हैं क्या और सफिशिएंट भी हैं। सो दैट आई शैल टेक इन द नेक्स्ट लेक्चर। स्टॉप हियर।